When most people think about bone, they think about something ossified, calcified, fossilized object. But human bone is anything but that. The other reaction people have is typically think about some other thing like this. Now, if you think of the basic structure of this particular show, it is also based on the perception that bone is something dead, and then you have to do some digging in order to find some truths about bones. And that is also false. In fact, bones, as in human bones, are alive. It's hardly ossified. The largest structure that we have inside our body is the bone. Now you might think that, okay, so what about the skin? Yes, but the bone performs a much, much larger function of the human body. To start with, bones produce hormones. Most people are surprised by this revelation that bones actually produce hormones. They do. For example, the fibroblast growth factor 23 or FGF23 is produced by the bone. We also know that it is controlled by one single gene. And we knew none of this before 2000. If you have too much of it, then you get rickety bones. If you have too little of it, then you get hyperglycemia. Now, either way, if it is too much or too little, you're dead. So there is an optimum value that has to exist in your body. And that's true for all hormones. There is always an optimal amount of hormone in your body. Consider any particular hormone. The other important hormone in the bones is osteocalcin. So let me ask the following question. Which hormone determines the fight and flight response in the human body? Typically we think of adrenaline, right? That's not true. The fight and flight hormone given to humans comes from osteocalcin. Again, this is something we did not know about for a long, long time. For example, osteocalcin, the basic functions have been known only in the last 15 years. 2007, when it was discovered that through osteocalcin, bones play a critical role in regulating blood sugar level. 2011, they discovered that the mice that do not produce osteocalcin have abnormally low levels of testosterone and therefore were sterile. And in 2013, they discovered that the mice whose skeleton did not produce osteocalcin were very, very anxious, very, very depressed, and were unable to master any kind of spatial structure. So what happens inside the bone with respect to osteocalcin? So think of this femur as a model for the bone. You have a whole bunch of things that come out of there. For example, the osteocalcin comes out and affects your brain. The osteocalcin comes out, affects your pancreas, which produces the insulin synthesis. It produces the muscle controlling objects from the bone as well as it controls human fertility through its secretion in the testes of humans. In 2019, they discovered that the fight and flight response really comes originally from the amygdala, that's inside our brain, and that detects the fear. It produces an osteoblast, and that generates the osteocalcin, which eventually produces the autonomous nervous system's fight or flight response. This was all done by the famous geneticist Gerard Carcenti. He wrote a paper in 2020 called That Feeling in Your Bones. And he used the phrase advisedly because when people talk about I'm feeling this in my bones, they really are feeling it in their bones. It's not an exaggeration at all. Now, what has all of this got to do with yoga? What we know is yoga actually increases osteocalcin production. Now, this was demonstrated very convincingly through a paper by Tori Stone from the University of Nevada, Las Vegas. Her study showed that she ran two groups of people. One were practicing kickboxing, the other was practicing yoga. And she showed that the increase in production of osteocalcin for women and for older individuals, for older women in particular, is enormously important. And what she showed, in addition, that kickboxing and yoga produced exactly the same amount of osteocalcin as a result of these exercises. So when we think about yoga, typically we think about something very gentle, very slow moving, whereas when we think of kickboxing, it is a very different kind of physical activity. Yet they produce the same kind of effect on osteocalcin. If you think about this whole thing, none of this was known before the year 2000. So less than a quarter of a century ago, we knew none of these things. And this has special implication for women for obvious reasons. For example, they generate biomarkers for humans when women have children. In other words, with a childbirth, the bones produce special rings so that by just examining the bones, we can figure out how many children that particular woman had. And therefore, as a result, the business about osteocalcin and all the other related things about the bones were not known just 25 years ago.